Let's talk a bit about the on-premise cloud. Basically, I'll try and give you some observations on what I've seen, a little bit about what's going on in our own firm, some other firms. And there are people in the audience, some of the vendors tonight who we've been working with. I'll call them out a bit later. Give you some flavours of why I think they're important, why I think there are some key technologies. So without further ado, let's press a button. Things my corporate comms and lawyer people make me say. Hopefully you know who Bank of America are. We have another website address that I won't talk about, but if you Google it, it's become quite famous on Finextra. Quickly, what I'm going to talk about, a little bit of view of the state of the nation. I'm going to talk a little bit about configuration management databases because they sort of play a story in the start of cloud. Talk a little bit about cloud types. I'm not going to give you the NCSA view. I'm not going to give you the bit that you get from Gartner. I'm going to give you a very different view of it, some slightly alternative pictures of it. Talk a little bit about what I think needs to go in a cloud, and then talk a bit about, well, if you're building one, some things you need to do. Hopefully that will give you a flavour for the evening. Two pictures, I think, that summarise why we've got into clouds. Lovely picture of real view of a data centre. Picture, I think if you walk into your own data centres, you'll find a horror like that. The reason we've got into cloud is to try and solve this sort of spaghetti slime, call it what you like, that has been created in data centres. We have built up many layers of technology. I've been in the city for about 28 years. There are still things running today that existed 28 years ago in the city. I can remember in year 2000 people talked about the instrument landing system at Heathrow, which was written in the 1950s then. All right, they've got rid of it now. But there's stuff in computing that has lasted for nearly 30 years in this business. So this stuff grows. If we then look at what the result of that growth is, you end up with a Harry Houdini picture. So basically the business is tied in knots. I know people like Gartner talk about the 70-30 rule. 70% is BAU, 30% is discretionary spend. I think we're probably nearer 80-20, even 90-10 in some cases. That we've got ourselves trapped in that we are having to maintain all this legacy. We actually don't know how it works. If you look at the attrition rate in the city, the number of people who hop around in jobs, I've been in the city, as I say, best part of 28 years. I've done 5 different jobs in that time. People move around, so knowledge disappears out of the organisation. So we've lost an understanding of how we got there. And cloud is seen as that simplification, and it's there to help Mr. Houdini escape his chains. The Houdini picture is significant from another point of view. Houdini had another kind of preoccupation in his life, and he liked to debunk charlatans. He spent a lot of time disrupting seances and things like that. And I'd like to talk about some charlatans very briefly. There are lots of organisations, and I think if we do the Alcoholics Anonymous admission here, how many people have done a CMDB program? Come on, hands up. How many of them really work well? What has delivered from your CMDB? How many are complete? They don't work, is the short answer. The reason they don't work is that you can't work out from a configuration how a system will behave. You can hide configuration anyway. You can hide configuration hard-coded in your bits of C program, hard-coded IP addresses, hard-coded web addresses. They're all buried in bits of code. Your CMDB will never find them. Even if you get into a database, there are how many database schemas in the world? One for every database in the world. You cannot capture those. So the notion of having a CMDB as a route to kind of see how your systems are made, and as that escape route to the cloud, it's not going to happen. So if you've got a CMDB program, throw it in the bin and think again. So let's move on let's look at some clouds. We're a bank. That's a very familiar picture to us. It's actually not a Bank of America ATM. I tried to find one. Couldn't find one handily. Salesforce is a very interesting form of cloud. We don't really know how Salesforce works. Any Salesforce people in the audience? Good. If you're talking to Salesforce and you want to ask them an awkward question, ask them how they add a data center. Because they can't explain how they add the next data center. They kind of have 2 at the moment. They're talking about 1 in Asia. What happens when they get to 10? They don't have a plan. Salesforce is interesting, though. We're a very big Salesforce customer, because what it does is it kind of segments how you look at your organization. It segments how you charge for things. You can define a function, so it's really very much software as a service, as people put that star AAS thing that you see. I just view it as a cash machine. It's very good. You pay for what you get. You put the card in, you say, I want 50 quid, and that's what you get. So think of it as a partitioning mechanism from a chargeback point of view, where you don't care how it's made. Another cloud. Quick quiz question. Anyone spot the peer? No. So, all Essex people, it's Clacton Pier. If you're an Essex person, it's Clacton Pier. The reason I use the pier analogy is Azure is a very interesting form of cloud because it relies on some very base services. Think of those as the piers on which the overall platform resides. It's a way of putting your toe in the water, getting past some of the slime that you have to deal with, but you're actually building something on the rock of some very base services, and then you're abstracting away from that sort of mess that you have in your organization. You're basically building a new platform above, but still using some of the core capabilities of your enterprise. Microsoft have done that pretty well. They've obviously got a lot of technology because they own Windows. That's their foundation for that. They own things like SQL Server. They own things like Active Directory. So they've been able to compose a cloud from some very well-defined, even if you don't necessarily believe in them, services. So rather than, say, the NCSA definition, think of that platform as a service thing, as you know, from the cloud definition. Think of it as a pier. You're basically building out over the sea, but you're still on hard foundations. So an interesting cloud. They've done some pretty good work there. They've had to re-architect a lot of their applications, and it will be interesting to see how their portfolio moves forward over the years as a result of Azure. Nigel is the great sailor here. So he immediately spotted it. It's RA. You want one of those, do you, Nigel? I always view Amazon as like being on Ra or Kon-Tiki. You're on the raft on the monstrous seas. You can go fishing over the side of the boat, but you've got to carry everything with you. So Amazon is, you do it all yourself. You're responsible for your own environment. They give you a sea to float on, but everything else is your problem to deal with. It's an interesting way of looking at cloud in that you get a virtual machine to run in. They give you an address. But what happens when you want to put some structure around that and run up 20 machines or 50 machines? You have to own that topology. They give you a bit of storage, and that's really as much as you get today. Interesting to see people are building services around it, so there are other rafts like the Oracle database stuff that's been announced. But still a very interesting sort of isolated model than this sort of more rigid structure that we saw in the earlier picture. So, what's in a cloud? If you want to build one yourself, first thing you need is to make some machines. How do you die stamp your virtual machines? Lots of people have kind of done that virtualization project. I think all of the banks here have done those server consolidation projects. They were done quite a long time ago now, 5-6 years ago. You still need to have a means of making machines. We're still quite bad at that. This is where I kind of talk about some of the people in the crowd. So Chris Purrington, give us a wave. So Chris's guys, Cohesive, have a very interesting cloud foundry technology. The idea of actually you can just make this stuff in software. What else have we got in there? Physical interconnect, how are you going to wire all this stuff together? I think we've got somebody from, was it Mellanox, somebody like that in the evening? They've got some bits tonight. We haven't got anybody doing monitoring tonight, have we? We're not going in monitoring space. The intuitive guys are doing some very good stuff in that space. How do you understand how machines interact with each other? Especially imagine in that RAR situation where you're in a fleet of RARs and one of them bumps into each other. How do you deal with that? They have some very interesting virtualization monitoring technology. Policy engine, how are you going to manage actually when one application misbehaves? How do you throw people off the cloud? How do you onboard them? You've got to have some structures around that. You need a control fabric. CloudSoft have some very interesting stuff in that space. Duncan, you can give us a wave at this point. He's on the panel later. They have this the Monterey fabric that has some very interesting scaling technologies. So you need one of those. Storage. How are you going to manage storage? We've all spent a lot of money on SAN and NAS over the year. How do you map that storage into your physical structures and how do you allocate it? I think storage, we've got a ways to go there, and I think we actually have to do more about naming and identifying how storage is attached with all its various services. So these are just some of the things you need. And some of the things to ask the people who design your cloud, have they thought about them? Scrutinise your design. This is my gratuitous railway shot. We put the boat shot in for Nigel. The reason I put that picture in is it's a drawing. It's got dimensions on it. So you actually have a measure of how much and how many. Cloud is actually all about sizing and scaling. So one of the things you've really got to think about is what's the size of each of your VMs, how do you allocate them, how much address space, how much storage. Really ask some very hard questions of the people who are designing clouds internally is, how does this stuff fit together? I might know that I have a virtual machine with 2 processors and X amounts of storage, but what's the structure of that when it relates to other things? Naming standards. We've just kicked off a great new debate about DNS standards and things like that in the bank, but it's not just about the DNS, the naming of the machines and how you divvy that up amongst departments. It's also about how you name things within an application. How do you identify where things are in the world? Because if you have this super VMs, the regulator's going to go hunting you down fairly soon and asking, well, how does this machine talk to this one and how do you know it's working? So think very hard about what the regulator's going to ask you about your virtual world, because they will come and ask, and machine ABC123 XYZ doesn't mean anything when it comes to data. And Nigel alluded to the data event that's coming next. Data and virtualization are 2 very interesting sort of things that are intersect in this space. So think very hard about that. It's a lovely poem, The Naming of Parts, that's why I put it up there. Ask questions of the people who are designing your clouds, how they name things. What can you learn from those names? If you get naming right, you can automate, because you can infer from one name what another name will be. But if you just pick random names, then you won't get any scale and you won't be able to audit and measure it. So, to summarise, on-premise clouds are really a portfolio segmentation strategy. It's about divvying up how you manage your IT. You can have some of it that you put the machines in a corner. They're still horribly stateful. They're not dynamic. They're not virtualized. But you put that cache machine in front of them. You're just managing them as a cost, or you're managing them as a chargeback mechanism. Other things you're managing because you're just managing your development estate. So think of the on-premise cloud as that segmentation strategy, and nothing more than that. And you can use any of those architectures I've talked about. The important thing, if you're going to build a cloud is about known knowns, as Donald Rumsfeld said. There are lots of challenges with known unknowns. We've been doing some interesting work in reference data about known unknowns. Unfortunately, I can't help you yet with unknown unknowns, but I'm working on that. Thank you very much.